Alright, in this video I'll be discussing formulas and applications. Actually, we have just one application. So here it says solve each formula or equation for the indicated letter. It says tip, solve step by step. Sometimes students try to do too many steps in one, so I just encourage you to take it step by step. Now, if you're going to be successful in this section, you got to be comfortable solving equations. So we're assuming that you're getting pretty comfortable solving the kinds of equations you would have seen in the previous section. Let's go ahead and get started, and you'll see how what we learned before with equations applies here. So I just want to mention something here. If I had 2x equals 5, when I solve this, I would divide each side by 2, and I would get x equals 5 halves. And we would say that 5 halves is the solution to the original equation 2x equals 5. So that's a little bit different than what we're doing here. We're not really solving these equations as much as we're manipulating them or rearranging them so that they're solved for a different variable. And this is an important skill in algebra. All right, so let's go ahead and get started. So first of all, on number 1, we're supposed to solve a equals bh for h. And so sometimes I will do this. I'll circle the letter that I'm trying to solve for, and basically I got to get rid of whatever else is on that same side other than the h in this case. So in this case I got to get rid of the b. And so you have b times h. The opposite of multiplying by b is dividing by b. So we're going to divide both sides by b. Whatever we do to one side, we'll do to the other. And so our b's cancel, and we're going to be left with a over b is equal to h. Now, if you prefer, you could write this as h equals a over b. It really doesn't matter which side the h is on. All right, let's move on to the next problem. In fact, I would encourage you to go ahead and try 2 and 3 and 4. All right, so let's see how you did. So by the way, I would just encourage you to stop the video, do the problems. You know, the more problems you're able to do on your own, the better off you'll be. And hopefully through the video, you'll correct any mistakes that you're having or making. All right, so on number 2, if I'm going to solve for r, I got to get rid of that t, and it's r times t. So we'll divide both sides by t. And when you do that, go ahead and cancel your t's. T over t is just 1. 1r, or r, is equal to d over t. And again, we can write that as r equals d over t. Doesn't really matter which side the r is on here. All right, so let's see how you did on 3. You're solving for m, and so you got to get rid of the c squared. Since it's m times c squared, we're going to divide, as we've done in the last 2 problems. So we'll cancel our c squareds, and we get m is equal to e over c squared. On number 4, this is a little different. Notice here you have 2 terms. And so this is not like the ones we've done before. So if I want to get rid of that 3x term, since it's really a plus 3x term here, to get rid of it I need to subtract 3x. 3x minus 3x would give me 0, and I would be left with y. So I'm going to go ahead and subtract 3x on both sides. On the left side, when I subtract, I'm just going to be left with y. And on the right side, now I could have written 8 minus 3x, but we normally put the x term or the variable term first, and then the constant, which is the 8 here, comes last. So if you said 8 minus 3x, it's not wrong, but this is the way I would prefer you write your answer. On number 5, we're solving for L. So first of all, keep in mind that we want to keep this term on this side, and let's get rid of the 2w. And so in order to do that, to get rid of that term, 2w, you'll have to subtract 2w. And of course, whatever you do to one side, you do to the other. we're going to get P minus 2W is equal to 2L. And now to get rid of the 2, since it's 2 times L, all we need to do is divide each side by 2. And so our final answer will be L is equal to P minus 2W all over 2. Now, you could have written that as P over 2 minus W, because 2W over 2 would be W. But there's really no reason to change it from the way it is here. All right, I would encourage you to try number 6, and if you can solve that one, you're doing great so far. All right, so let's see how you did. So again, we don't want to mess with our by term. We're trying to solve for y. So we need to get rid of the ax term by subtracting ax on both sides. We're going to get by equals c minus ax. And again, if I want to solve for y here, I got to get rid of the b. So let's divide each side by b. And so we're going to get y equals c minus ax all over b. All right, let's move on to the next slide. Now on number 7, notice we have a fraction here. And in fact, when we were solving equations, we learned with the technique that I taught you, the first thing we always want to take care of is fractions. And so in this case, before you even think about solving for h, you want to get rid of that fraction. Well, the way we do that is by clearing fractions. So our LCD here is 2. There's only one denominator. And so when we multiply both sides by 2, the fraction should go away. So let's go ahead and do that. We're going to get 2a is equal to bh. Remember, 2 times a half is 1. Those are reciprocals. You can think of it as 2 over 1 times 1 over 2. When you multiply, you get 1, and 1 times bh is bh. So now we just need to get rid of that b. Let's divide each side by b. So our b's cancel. We're left with h equals 2a all over b. All right. I would encourage you to try number 8 and maybe even number 9. All right, so let's see how you did. So first of all, you should have multiplied each side by 3. You get 3k equals mn. And then say I'm solving for m, so I need to get rid of that n. We'll divide each side by n. Of course, the n's cancel, and you're left with m is equal to 3k over n. On number 9, it's very similar, but you got to be just a little bit careful here. We're going to multiply both sides by 2. So we're going to get 2a is equal to a plus b. So be careful on the right side. You're basically multiplying 2 over 1 times a plus b over 2. Now you could multiply that out. You'd have 2 times a plus b. You don't want to distribute over 2, and then basically these 2's cancel. So the way I normally do it is I just cancel here, and you can see you have a plus b over 1, or just a plus b. All right, so let's continue. We're almost done. We just need to get rid of the a, and since that's a term, we'll subtract a on both sides. And so we have 2 times big A minus little a is equal to b. Notice it's important that you write the capital A and the lowercase a differently. These are 2 different variables here. All right, so I would encourage you to try number 10. It's very similar to one we just did. And then I would challenge you to try number 11. That one has a different twist on it, and unless you recall something from your past, you may or may not be able to do that one. Let's see what you can do. All right, so let's see. On number 10, I've got to multiply by n to clear fractions, so we'll do that on each side. So we're going to get nb is equal to h minus k. Remember, these n's cancel here, and you're left with 1 times h minus k, or just h minus k. By the way, if I wanted to, I could write this as bn or nb. I'm not sure in my math lab if it's going to care, but generally we tend to put them in alphabetical order. So I'll do that at the end. And so I'm solving for h, so I need to get rid of that minus k term by adding k to both sides. So we have NB plus K is equal to H, or again, the other way to write this would be H equals capital B times N plus K. All right, so let's see how you did on 11. So on the left, we just have M. Now on the right, the problem is, first of all, these are not like terms because they don't have the same variable factors. This term has P and R as variable factors. So like terms have to have all the same variable factors. So these aren't like terms. I can't just subtract them as they are. So really the only thing we can do is factor out an H. This is something you may or may not remember. It's something we'll talk about more later. But for now, we're basically doing the distributive property in reverse. So I'm going to pull an H out front. And so H times something should give me H. That goes here, H times 1. And H times something else should give me this term. Well, it's going to be a minus, and I need PR. So it'll be minus PR. So remember the distributive property, we have H times 1 is H, and H times a minus PR gives us the minus HPR. Let me erase that so you can see things. And so that's the trick right there. You got to know how to factor out the H there. And so now we need to get H by itself, so we just need to get rid of all this. So that's what we're going to divide by on both sides, since it's H times that amount. And when we do that, notice here these are going to cancel, and we're left with H equals M over 1 minus PR. So now you ought to be able to do number 12. Go ahead and try that one. All right, so on the left you have A equals, you should have factored out a P times the quantity 1 plus RT. So we'll, in order to get P by itself, since it's P times this quantity, we needed to divide. So we'll divide each side by 1 plus RT. We're going to get P is equal to capital A over 1 plus RT. All right, we have got one more problem to do. So here it says the formula for projecting human birth weight is given by this formula, where P is the projected birth weight in grams, D is the diameter of the head in centimeters, and A is the circumference of the abdomen in centimeters at 29 weeks. So they use an ultrasound to measure these things. So all to say, this is what I call a plug and chug type of situation. We basically have a formula, and we're going to plug in the numbers. And normally, in this case, there's 3 variables, P, D, and A. So we're expecting they'll give us 2, and we're going to have to find the third. So that's the chug part of the plug and chug. All right, so I'm going to go ahead and write down the formula. And now notice the head of the diameter, that's my D, so that's my 8.1. The abdominal circumference of 32.5, that's going to be my A. And so now we're ready to plug that into the formula. I'm going to go ahead and do that. And when you do that, you should get 2,457.1 gram. Now, if you know your metric system, you know we don't normally write an answer that way because 1,000 grams makes 1 kilogram. So I think in the book or in my math lab, your answer will be like this. But honestly, you would normally write this as 2.4571 kilograms, or you might round it to like 2.5 kilograms. All right, so in part B, we're going to actually take our formula and we're going to solve it for A. Again, we're going to rearrange the formula so that it's solved for A. So basically, I got to get this A by itself. So I've got a lot of work to do. So actually, not too much. First of all, I want to get rid of that other term. So let's get rid of that minus 299 by adding 299 to both sides. So first of all, we're going to have to keep this term if we're going to solve for A. So we're getting rid of the other one. We get P plus 299 is equal to 9.3337 dA. And honestly, this is all multiplication on the right side here. And we're trying to solve for a, so we just need to get rid of these two numbers here, which are multiplied times a. And so we're going to divide by 9.3337d. And of course, we got to do that on both sides. So finally, notice these guys canceled out here. So finally, we get a is equal to p plus 299 over 9.3337d. All right, and that's it for this video.